The requests library is one of the most widely used Python libraries for making HTTP, HyperText Transfer Protocol, requests. In a cybersecurity and automation context, it allows you to interact programmatically with web servers and web application programming interfaces, simulate browser behavior, analyze server responses, and detect potential vulnerabilities. This course introduces the core concepts and practical usage of the requests library, with a focus on HTTP request construction and HTTP header analysis, two essential skills for any penetration tester or security automation specialist. Before diving in, it is worth noting that you have already worked with sockets at a lower level, manipulating raw network connections to scan ports. The requests library operates at a higher level of abstraction. Instead of dealing with bytes and TCP, transmission control protocol, handshakes directly, you work with structured HTTP messages. This makes it far easier to interact with modern web applications, which is where the majority of today's attack surface lies. Installing and importing the requests library. The requests library is not part of Python's standard library, so it must be installed separately. You can install it using the pip package manager with the command pip install requests. Once installed, you import it in your script as follows. Import requests. This gives you access to all the functions and objects you need to send HTTP requests and inspect responses. Understanding HTTP requests. An HTTP request is a message sent from a client, such as a browser or your Python script, to a web server. Every HTTP request is composed of several parts. A method, also called a verb. The most common are get, post, put, delete, patch, head, and options. A uniform resource locator, URL. The address of the resource being requested, for example, https://example.com/login. Headers, key value pairs that provide metadata about the request, such as the type of content being sent, authentication tokens, or the identity of the client. A body, optional, data sent along with the request, typically used with post or put methods. In penetration testing, understanding and manipulating each of these components is fundamental. For example, changing a request method from GET to POST, or modifying a header value, can reveal vulnerabilities in how the server handles input. Making a basic GET request. The GET method is used to retrieve a resource from a server without modifying it. Here is a basic example. Response equals request.get https://example.com. This single line sends an HTTP GET request to https://example.com and stores the server's response in the variable called response. The response object contains everything the server sent back: the status code, the headers, and the body. To access the HTTP status code, a 3-digit number indicating whether the request succeeded or failed, you use print response.status_code. Common status codes include 200. The request was successful and the server returned the requested content. 301 or 302. Redirection. The resource has moved to another address. 400. Bad request. The server could not understand the request. 401. Unauthorized. Authentication is required. 403. Forbidden. The server understood the request but refuses to authorize it. 404. Not found. The requested resource does not exist. 500. Internal server error. Something went wrong on the server side. These status codes are extremely relevant in security testing. A 403 where a 404 was expected may indicate that a resource exists but is protected. A 500 may reveal that the server is crashing due to unexpected input, which could point to an injection vulnerability. Making a POST request. The POST method is used to send data to the server, typically to submit a form or log in to an application. Here is an example of a login simulation. Payload equals username, admin, password, password 123 response equals requests.post https://example.com/login, data equals payload. In this example, the dictionary called payload contains the form fields. The request.post function sends this data in the body of the HTTP request, just as a web browser would when a user submits a login form. For applications that expect data in JavaScript object notation, JSON, format rather than standard form encoding, you use the JSON parameter instead of data. Payload equals username, admin, password, password 123 response equals requests.post https://example.com/API/login, JSON equals payload. When using the JSON parameter, the requests library automatically sets the content type header to application/JSON. which tells the server how to interpret the body. Analyzing HTTP response headers. HTTP response headers are key value pairs sent by the server alongside the response body. They carry important metadata that is extremely useful in security assessments. You can access response headers through the headers attribute of the response object. Print response.headers. This returns a dictionary-like object. You can access individual headers like this. Print response.headers.get content type. Print response.headers.get server. Here are the most security-relevant response headers to look for. Server reveals the web server software and version, for example, Apache/2.4.49 or Nginx/1.18.0. Exposing this information helps attackers identify known vulnerabilities in specific software versions. A well-hardened server will suppress or obfuscate this value. X powered by reveals the back-end technology, for example, PHP/7.4.3 or ASP.NET. Like the server header, this is considered an information disclosure risk. Strict transport security tells the browser to only connect to the server over HTTPS, HyperText Transfer Protocol secure, for a specified period. Its absence may mean the site is vulnerable to protocol downgrade attacks. X content type options, when set to no sniff, prevents browsers from interpreting files as a different type than declared. Its absence can enable certain types of content injection attacks. X-frame options controls whether the site can be embedded in an E-frame. Values include DENI and semi-origin. Its absence may allow clickjacking attacks. Content security policy defines which sources of content, scripts, images, styles, the browser is allowed to load. A missing or weak policy increases the risk of cross-site scripting attacks. Set cookie used to set cookies on the client. Security-relevant attributes include HTTP only, prevents JavaScript from accessing the cookie, secure, only send the cookie over HTTPS, and same site, controls cross-site request behavior. Missing these attributes can expose session tokens to theft. In a penetration test, systematically reviewing these headers is part of the reconnaissance and vulnerability identification phase. A script that automatically checks for missing or misconfigured headers can save hours of manual work. Customizing request headers. Just as you can read the headers sent by the server, you can also send custom headers with your requests. This is essential for simulating authenticated requests, bypassing naive filters, or testing how the server handles unexpected input. Here is how to send a custom user agent, a header that identifies the client making the request, and an authentication token. Headers equals user agent, Mozilla/5.0, compatible, security scanner /1.0. Authorization, bearer AJHB GCI OIJUZI 1 NI is inner 5 CCI 6 IKPX FCG 9. Response equals requests.get https://example.com/API/data, headers equals headers. In security testing, the user agent header is often manipulated to bypass restrictions. Some servers block requests that do not look like a browser, or to test whether the server applies different logic based on the client identity. Handling sessions and cookies. In many web applications, authentication state is maintained through cookies. The requests library provides a session object that automatically handles cookies across multiple requests, mimicking browser behavior. Session equals requests.session session.post https://example.com/login, data equals username, admin, password, secret response equals session.get https://example.com/dashboard. After the post to the login endpoint, the session automatically stores the authentication cookie returned by the server. The subsequent get to /dashboard is then sent with that cookie, granting access as if you were a logged-in user. This is particularly useful for automated testing of authenticated areas of an application, a core activity in web application penetration testing. Handling redirects and timeouts. By default, the requests library follows HTTP redirects automatically. You can disable this behavior, which is useful when testing whether a redirect itself leaks sensitive information. Response equals requests.get https://example.com. Allow _redirects equals false print response.status _code print response.headers.get location. Timeouts are equally important for automation scripts. Without a timeout, a script can hang indefinitely if a server is slow or unresponsive. Always specify a timeout. Response equals requests.get https://example.com, timeout equals 5. This sets a maximum wait of 5 seconds. If the server does not respond within that time, a timeout exception is raised. which you should handle in your code. Accessing the response body. The body of the response, the actual content returned by the server, can be accessed in several ways. Response.text returns the body as a plain text string, decoded according to the response's character encoding. Response.content returns the raw bytes, useful for binary content such as images or files. Response.json parses the body as JSON and returns a Python dictionary. This raises an exception if the body is not valid JSON. For security testing, response.text is often used to search for leaked information, error messages, stack traces, version numbers, within the HTML or JSON response. You can combine this with the regular expression techniques you have already studied to extract specific patterns from responses. Disabling certificate verification with caution. During testing of internal or development environments, you may encounter servers using self-signed transport layer security certificates, which would normally cause the request library to raise a certificate verification error. You can disable this check. Response equals request.get https://internal target.local, verify equals false. However, this should only be done in controlled, authorized testing environments. Disabling certificate verification in production code exposes the application to man-in-the-middle attacks. When you disable it, the library will also display a warning, which you can suppress by importing the erlib3 module and calling erlib3.disable_warnings. Practical security automation example. Here is a simple but realistic example that combines everything covered in this course. The script sends a GET request to a target URL, checks for missing security headers, and prints a basic report. Import requests. Target equals https://example.com. Response equals request.getTarget, timeout equals 5. Security_headers equals. Strict transport security. X content type options. X frame options. Content security policy. Printf status code. Response.status_code print server. Response.headers.getServer. Not disclosed print \n missing security headers, for header and security_headers. If header not in response.headers. Printf, header, is missing. This kind of script is a building block for automated reconnaissance tools, and can be extended to scan multiple targets, output results to a CSV, separated values, or JSON file, as you learned in your reports module, and integrated into a larger penetration testing workflow. Key takeaways. The requests library is an indispensable tool in the Python Security Automation Toolkit. It abstracts the complexity of the HTTP protocol, letting you focus on what matters in a security context, crafting meaningful requests, inspecting server responses, and identifying weaknesses in how headers, cookies, and response codes are managed. Mastering this library bridges the gap between low-level network programming, which you explored with sockets, and high-level web application testing. Every concept covered here, methods, headers, status codes, sessions, timeouts, and response parsing, will appear repeatedly in the web penetration testing and DevSecOps automation work that follows.